On the morning of the 16th of April 1945, USS Laffey, DD-724, was holding Radar Picket Station Number 1, about 49 nautical miles north of Okinawa. Just after 8:27 in the morning, her radar scope showed enemy aircraft approaching from the north. Within minutes, the destroyer was under one of the hardest air attacks any single American warship would survive in the Pacific. A bomb burst near the stern and severed electrical cables and hydraulic lines to the steering gear. The rudder jammed 26 degrees to port. Laffey could no longer answer the helm properly. She could only circle. Fires spread aft. Smoke rolled through compartments. Parts of the ship lost power. And still the crew kept firing. That is the moment people remember. Gun crews working in local control. Men cranking mounts by hand after electrical control failed. Orders shouted over damaged circuits. Ensign Jim Townsley climbing above the pilothouse with a microphone strapped to his neck, feeding commands into the loudspeaker system because normal communications had been cut. Commander Frederick Julian Becton refusing to consider abandoning ship. His answer was blunt. No, I'll never abandon ship as long as a single gun will fire. It was not rhetoric. At that point, it was a technical statement. If one mount could still bear, one loader could still lift, and one trainer could still swing a barrel, the fight continued. To understand why Laffey could still fight in that condition, you have to step back from Okinawa and look at the problem the U.S. Navy had spent the war trying to solve. Before the Pacific War turned into a radar war and then an anti-aircraft war, destroyer doctrine still carried a heavy inheritance from the 1930s. Destroyers were expected to screen the battle line, launch torpedo attacks, hunt submarines, and if necessary, engage other destroyers at night. That doctrine had not vanished, but by 1942 it was no longer enough. At Guadalcanal, in the Solomons, and across the carrier war, the destroyer had become something else: escort, rescue ship, fighter direction platform, shore bombardment ship, anti-aircraft battery, and damage control testbed, all in one narrow steel hull. The older destroyer designs could do much of that work, but not comfortably, and not with much room left over. The Benson and Gleaves types had been good ships, but they were cramped. The Fletcher class was a major improvement, yet wartime demands kept piling on: more radar sets, more communications gear, more ready ammunition, and heavier anti-aircraft batteries. The Navy wanted a destroyer that could carry 6 5-inch 38 caliber dual-purpose guns in 3 enclosed twin mounts, keep heavy short-range anti-aircraft weapons, preserve torpedo punch, and still be rushed into serial production without stopping the yards. That was the real demand behind the ship that fought off Okinawa. Not elegance, not theory, but a hull that could do more jobs at once and survive longer while doing them. The push for that ship began while the first Fletcher-class destroyers were still taking shape in the summer of 1941. The General Board wanted a larger destroyer built around 6 dual-purpose guns. The problem was practical. You could draw anything on paper. Building it in wartime, without slowing the flood of ships already ordered under the Two-Ocean Navy expansion, was something else. The answer came when the lighter Mark 32 twin 5-inch mount became available. It had originally been developed as secondary anti-aircraft armament for larger ships, but it now made a 6-gun destroyer feasible without requiring a completely new engineering plant. The men behind the design were not romantic figures. They were bureau officers, planners, and yard managers working under a calendar that did not care about comfort. The Bureau of Ships had to preserve as much of the Fletcher machinery and hull practice as possible. The Bureau of Ordnance wanted more firepower and better anti-aircraft arcs. Fleet commanders wanted a ship that could still turn, still steam hard, and still take damage without becoming dead weight in the water. The compromise was clever and unsentimental. Keep the basic Fletcher machinery, widen the beam by 14 inches, fit twin rudders for tighter maneuvering, increase generating capacity to 800 kilowatts, with an additional 200 kilowatt diesel standby supply, except that the ship would be a little heavier and a little slower. Get it built. That design became the Allen the 1000th, Sumner class. 69 hulls were ordered on the 7th of August 1942. Only 6 builders had to retool for the new class. compared with the broader industrial spread that had turned out the Fletcher class. Bath Iron Works made the transition quickly. The first Sumner hull laid down there went on the blocks on the 24th of May 1943. The first completed ship of the class, USS Barton, DD-722, was commissioned on the 30th of December 1943. The class measured 376 feet 6 inches in length, displaced about 2,200 tons standard, and carried a war loadout that told you exactly what the Navy expected from it. 6 5-inch guns, strong medium and light anti-aircraft batteries, 10 torpedo tubes, depth charges, radar, and the crew to run all of it at once. It was not perfect. The early bridge arrangement proved cramped. The ships were considered bow-heavy because the weight of the 3 twin mounts was spread toward the ends of the hull. On trials, Barton made 34.2 knots, less than the speed many destroyer officers wanted on paper. But this was the key difference between paper and war. The Sumner class was not built for the clean destroyer duel imagined before Pearl Harbor. It was built for crowded task groups, shore bombardment, radar warning, and sustained anti-aircraft work under constant strain. In other words, it was built for the war that actually arrived. Laffey herself was laid down at Bath on the 28th of June 1943, launched on the 21st of November, and commissioned on the 8th of February 1944 with Becton in command. She joined Destroyer Division 119, a group of new Sumner-class ships named after destroyers lost in the Guadalcanal fighting. That fact mattered. These were not abstract design studies. They were replacements for hard losses. Laffey went first to the Atlantic, not the Pacific, and reached the invasion front in time for Operation Neptune. On the 6th of June 1944, she was off Utah Beach. She screened seaward on D-Day, bombarded gun positions on the following days, and on the 25th of June stood in toward Cherbourg under fire from German shore batteries. A shell ricocheted into her above the waterline and did not explode. It was the kind of luck sailors remember for the rest of their lives. By late summer, she had crossed to the Pacific. There she did what American destroyers kept doing whenever the war map changed. She screened carriers of Task Force 58. She covered landings at Ormoc Bay and Mindoro. She shelled troop concentrations and shore batteries. She screened bombardment groups in Lingayen Gulf. She supported the strikes tied to Iwo Jima. Then, in March 1945, she moved with the force gathering for Okinawa, the largest amphibious assault of the Pacific War. A campaign assembled with more than 1,600 ships and roughly 350,000 naval personnel. The American objective was plain enough. Take Okinawa and remove the last barrier between American air and sea power and the Japanese home islands. Here the contrast with the Japanese destroyer tradition becomes clear. The Imperial Japanese Navy had built ships like the Yugamo class around the night torpedo battle. 19 of those destroyers were built between 1940 and 1944. They carried the Type 93 Long Lance torpedo, one of the deadliest weapons of the war, and 6 127mm guns in 3 twin turrets. On paper, those guns looked dual-purpose. In practice, their anti-aircraft value was badly limited by slow training speed, slow firing cycles, weak high-angle fire control, and the lack of effective radar-assisted gunnery. American destroyer design had gone in the opposite direction. The Sumner class still carried torpedoes, but its real edge was radar, dual-purpose battery control, electrical power, communications, and damage control. Japanese destroyers were built to hit hard at night. American destroyers were increasingly built to stay in the fight when the whole sky came down on them. Okinawa exposed the cost of both approaches. To protect the landing area, the Navy ringed the island with radar picket stations. These outlying destroyers were supposed to see the attackers first, vector combat air patrol fighters toward them, and give the main fleet time to brace. In theory, each station should have been heavily manned. In practice, there were never enough ships. The pickets became isolated targets, and Japanese planners understood exactly what they were. Knock out the pickets, and you blind the fleet. By the time of the big Kikasui attacks, Japanese aviators were no longer simply diving at the nearest ship in panic. They were staggering their approaches by altitude, speed, course, and timing. Small groups came in from different bearings. Some aircraft drew away the fighters. Others followed low. Often, they aimed for the first ships they saw. That usually meant the destroyers. Laffey reached that environment in mid-April. At Radar Picket Station Number 1, she was accompanied by smaller support craft, and almost immediately found herself helping beat off earlier raids. Then came the morning attack that fixed her in naval memory. Over the course of about 80 minutes, the ship endured repeated assaults by Val dive bombers, Judy dive bombers, and Army Oscar fighters, while American fighters from nearby carriers tangled with the attackers directly over the ship. Laffey shot down enemy aircraft on her own and in combination with the combat air patrol, but gunfire alone could not stop everything. One plane smashed into the ship, then another. Bombs hit. A plane clipped the air search radar. The after deckhouse burned fiercely. Mounts were wrecked. Ammunition cooked off. Men were blown overboard. What saved the ship was not one dramatic gesture, but a chain of ordinary, filthy, dangerous jobs done correctly under impossible pressure. In the aft engine room, machinist's mate John McKell shut down the supply fans as smoke thickened and temperature climbed to 130 degrees. Later, with machinist's mate Buford Thompson, he helped get air to trapped shipmates. George Logan and Stephen Waite, also machinist's mates, had been fighting fires when buckled escape hatches trapped them. Art Hogan and Elton Peeler cut through steel with torches to pull them free. Topside, Lieutenant Matt Darnell ran a makeshift aid station after fragments sheared off the tips of 2 fingers. He wrapped the wound and kept treating the injured. Signalman Tom McCarthy saw the colors shot down, climbed the mast, and bent on a new flag. Bridge lookout Feline Salcedo shoved Becton down a split second before exploding fragments swept the bridge. This is the part many summaries miss. A destroyer survives by mechanics, welders, loaders, talkers, and medics long before it survives by legend. Even the gunnery became improvised labor. With circuits ruined and communications shredded, Townsley's loudspeaker rig became the ship's nervous system. Gun crews shifted to local manual control, trainers and pointers cranked by muscle. Loaders wrestled heavy ammunition in heat and smoke. When one attacker bored in low, a damaged mount working without normal electrical control still got on target and killed it with 2 rounds. Men in gun tubs kicked hot clips aside and hosed down ready ammunition near burning aviation gasoline. The ship circled uselessly under that jammed rudder. Yet because the engineers kept steam, the generators kept enough life, and the gun crews kept discipline, Laffey never became a helpless target. She became a crippled ship that still bit back. The scale of the wider battle makes that survival even harder to appreciate. Around Okinawa, there were 16 radar picket stations. Japanese plans called for the use of thousands of aircraft during the campaign, with vast numbers earmarked for suicide attacks. On the 6th of April alone, the first mass Kikusui strike sent 355 kamikaze aircraft against the fleet. During the Okinawa campaign as a whole, 149 Allied ships were hit or sunk by kamikaze attack, and 88 of those were destroyers or destroyer types, with another 30 destroyer escorts also struck. That is the real arithmetic of the picket line. The light ships on the perimeter carried a disproportionate share of the danger because they were the warning system. They were the alarm bell, and the enemy learned to smash the bell first. There was an industrial dimension to this as well. The United States could answer loss with construction. Japan increasingly could not. The Sumner program alone produced 58 destroyers, with another dozen hulls completed as fast mine layers. The class went from drawing board compromise to serial production in wartime yards already running flat out. Japan's destroyer force, by contrast, was being ground down by attrition, fuel shortages, and a war economy under air and submarine attack. The Japanese still built dangerous ships and flew desperate, often effective attacks, but by 1945 they were trying to solve an industrial collapse with suicide tactics that could inflict terrible local damage. It could not reverse the balance. After the attack finally broke off, Laffey was a ruin that still floated. Her after 5-inch mount was destroyed. Much of her light anti-aircraft battery had been smashed. Fires had ravaged the after superstructure. Casualties came to 103, including 32 dead or missing and 71 wounded. Yet she was not finished. Smaller craft came alongside to help fight fires and pick men out of the water. The destroyer minesweeper Macomb took her in tow. Tugs later helped bring her in. Temporary repairs got her to Saipan, and from there she made the long trip back to the American West Coast for full repair. Her crew earned the Presidential Unit Citation. Becton received the Navy Cross. Post-war official assessments would say radar pickets had been an unqualified success in early warning, but at considerable loss and damage. That sentence contains both the achievement and the bill. So what is the final verdict on the ship that fought in circles off Okinawa? Laffey was not proof that any doctrine had solved modern naval war. If anything, the radar picket system showed how brutally expensive even a successful method could be. But the Allen the 1000th Sumner type did exactly what the Navy had asked of it when the class was conceived in wartime urgency. It delivered more dual-purpose firepower, more electrical capacity, more control, and more resilience in a destroyer hull that the yards could actually build fast. It succeeded through utility, through numbers, and through the grim fact that American crews were trained to improvise damage control while the battle was still in progress. That is why Laffey stayed alive, not because she was invulnerable, because she was built for a very hard kind of flexibility, and manned by people who knew how to turn wreckage back into function. And that brings us back to the opening scene. A destroyer north of Okinawa. Steering jammed, power damaged, smoke in the compartments, men hauling shells, cutting steel, dressing wounds, and talking to gun mounts over a jury-rigged loudspeaker while the ship circles under attack. The phrase, "the ship that would not die," is memorable, but it can hide the real story if we let it. Steel does not make that choice. Systems do not make that choice. Sailors do. On the 16th of April 1945, USS Laffey remained in action because enough of her crew, in enough compartments, kept doing their jobs after the machinery failed in front of them. That is the part worth holding on to. If you have a relative who served during this era, who operated, built, or fought alongside one of these machines, I would be honored to read their name, their unit, and their year in the comments below. Their stories are worth keeping alive. If this story gave you something you hadn't heard before, hit the like button. It tells the platform to put careful, sourced history in front of more people who actually want it. Subscribe if you want the next one.